Good day, Mom and everyone. Our topic for today is characteristic of molecules. For our learning points, first is to determine the molecular mass of a molecule and predict the general shape of a simple covalent molecule. And the last is compare the properties of ionic and molecular compounds.
So hello everyone. Our topic for today is all about characteristics of molecules. No, unlike the ions in ionic compounds, which are arranged in lattices called crystals, molecules of covalent compounds exist as discrete units with a characteristics mass and a certain three-dimensional shape. So, ang molecular mass is the mass of a molecule. That molecular mass, sometimes called the molecular weight, is simply the sum of the masses of its atoms. As with formula masses, it is important that you keep track of the number of atoms of each element in the molecular formula to obtain the correct molecular mass. No, so sabi diyan, no, so para makuha daw natin yung molecular formula, kailangan nating hanapin yung number of atoms. So, para daw makuha natin yung molecular formula is kailangan nating hanapin yung number of atoms ng mga elements. So, for example, yung H2O, no? Kung makikita natin sa PPT natin is merong 2 atoms yung hydrogen, no? So, kung makikita natin yung kanyang atomic mass is 1.01. Pero kung makikita natin sa periodic table, no? Yung ating atomic mass is 1.008. So yun is bakit siya naging 0.01 kasi parang para makuha natin yung AMU or yung atomic mass unit is kailangan nating mag-base, no, sa periodic table natin in section 2.7, no. Sabi dito, the molecular formula of H2O indicates that there are 2 hydrogen atoms and 1 oxygen atom in each molecule, summing masses of these atoms, no. So makikita natin yung hydrogen is meron siyang 2 atoms, then yung kanyang atomic mass is 1.01. So ipapag times natin yung dalawa na yun, is ang magiging equivalent niya is 2.02 atomic mass unit. So punta namin tayo sa oxygen. So ang oxygen is meron siyang invisible 1 na atoms. Then ang kanyang atomic mass is 16.00 atomic mass unit. So ang gagawin natin, yung kanilang sagot sa dalawa na yon is ipapag-plus natin sila. So 2.0 mu plus 16.00 mu is equals to 18.02 mu. So ang molecular mass ng H2O is 18.02 mu. Example natin is yung C6H6 and in 78.12 mu. So sa 6C is meron tayong 6 atoms na meron siyang atomic mass na 12.01 and equals to 72.06 mu. Then sa 6H naman or hydrogen is meron siyang 6 atoms, no? 6 times 1.01 is equals to 6.06 mu. Then uulitin natin yung step niya lang, ipapag-plus lang natin yung sagot ng dalawa is yun ay 72.06 mu plus 6.06 mu is equals to 78.12 mu. So the molecular mass of C6H6 is 78.12 mu. Then sa ibang example is tuloy-tuloy nyo lang gawin yon para makuha natin yung atomic mass unit ng isang element. So dako naman tayo sa molecular shape na or yung BSEPR theory, no? Unlike ionic compounds with their extended crystal lassities, covalent molecules are discrete units with specific three-dimensional shapes. The shape of molecule is determined by the fact that covalent bonds which are composed of negatively charged electrons, tend to repel one another. This concept is called the valence shell electron pair repulsion, or BSEPR theory. For example, the two covalent bond in BCl2 stay as far from each other as possible, ending up 18, 18 degrees 180 degrees apart from each other. The result is linear molecule. So, ang linear molecule, guys, is meron siyang two bonding pairs of electrons around the central atom, no? Form a linear shape with a 180 bond angle. Is yung trigonal planar. Molecules with three bonding pairs of electrons around central atom. No? So, for example, is yung BF3 form, a trigonal planar shape with 120 bond angles. No? So, meron siyang isang atoms at hinuhold niya yung 3 atoms. So, nagpo-form siya ng 120 degree yung tetrahedral molecules, no? With 4 bonding pairs of electrons around the central atom, form a tetrahedral shape with approximately 109.0 degree bonds angles. Molecules with lone pairs, the presence of lone electron pairs, non-bonding pair electrons on the central atom affects the molecular shape. For example, ammonia, NH3, one lone pair and 3 bonding pairs result in a trigonal pyramidal shape.
So let's move on to molecules with lone pairs around central atom. Molecules with lone electron pair around the central atom have a shape based on position of the atoms, not the electron pairs. For example, ammonia has one lone electron pair and 3 bonded electron pairs. These 4 electron pairs repel each other and adopt tetrahedral arrangement. However, the shape of the molecule is described in terms of positions of the atoms, not the lone electron pairs. This explains how the geometry of a molecule is determined based on the number of the bonds and lone pairs around the central atom, involving ammonium ion and ammonia. For our example, ammonium ion and ammonia. For the ammonium ion, central nitrogen atom has 4 bonds and no lone pairs. According to the table, this makes it a tetrahedral shape and has no lone pairs. For the ammonia, central nitrogen atom has 3 bonds and 1 lone pair. According to the table, this gives the trigonal pyramidal shape and has 1 lone pair. Makikita nyo naman sa PPT. So we have 2 types of molecules, the nonpolar and polar molecules. Nonpolar molecules is generally nonpolar if all bonds are nonpolar or if polar bonds are arranged symmetrically so their polarities cancel each other out. Polar molecules if it contains polar bonds and the geometry of the molecule prevents the bond polarities from canceling each other. So, yes. In conclusion, the text explains that a molecule shape is determined by the arrangement of electron pairs around the central atom, and this shape directly impacts whether the molecule is polar or nonpolar based on whether the polarities cancel each other. That's the end of our report.